In this lab, we will continue with the time series analysis of the COVID cases. In step 1, we loaded the time series data for confirmed COVID death and the recovered cases of the COVID. And in step 2, we plotted the graphs for confirmed, recovered, and the death cases. And in step 3, we found the proportion of confirmed, recovered, and death cases, and we plotted for 2020 and 2021 and after, and we compared the proportions. And in step 4, we performed autoregressive integrated moving average prediction on the confirmed data to predict the number of cases in New Zealand. And we found the parameters for autoregressive integrated moving average model of P equal 3, Q equal D equal 2 is the one which gives the best prediction. Then in step 5, we performed cross-validation on the prediction to evaluate the model's performance. And we concluded that the cross-validation is better than comparing the IIC value. Then in step 6, we will look at do moving average. With varied time series data, sometimes it is useful to use a moving average process to smooth out the sudden changes in the data. A moving average is a statistical technique used to smooth out data by calculating the average of data points over a specific window of time or number of observations. The idea is to remove fluctuations and noise to better reveal the underlying trend or pattern in the data. Moving averages are commonly used in time series analysis and financial market analysis, but they can be applied to any list of numerical data. How does it work? In a simple moving average, for each point in time, you take the average of the surrounding data points within the specified window. For instance, if you have daily data and you are calculating a 7-day moving average, the average for day 7 would be the average of days 1 through 7. The average of day 8 would be the average of days 2 through 8, and so on. Let's say we have this simple series of numbers 4865324 and we want to calculate a 3-day moving average. The first average would be 4 plus 8 plus 6 divided by 3, which is equal to 18 divided by 3, which is equal to 6. The second average would be 8 plus 6 plus 5 divided by 3, which is 19 divided by 3, which is equal to 6.33. The third average would be 6 plus 5 plus 3, which is 14, and then divide by 3, which is 4.67, and so on. The moving average series would then be, the first two values will be nan, those values will be missing, and the rest of the values will be there. The first two entries are nan because we don't have enough data points to calculate the moving average for those days. Types of moving average: simple moving average. the straightforward average of n previous data points. Exponential moving average prioritizes more recent data points by applying more weight to them. Weighted moving average allows you to specify weights for different data points within the window. Uses identifying trends in data, smoothing out noisy data, forecasting future values based on patterns, signal generation for trading systems. First, let's create a difference series, confirm New Zealand diff from confirm New Zealand, where the value is the number of daily cases. Let's just make this series so that it has data from day 700 onwards. Day 700 from the first day up to now. Hence, the original data is a cumulative sum. So the original data, for example, on 22 January 2000 was the sum of the data, all the data up to 22 first 2020. So our difference function from pandas is sufficient to find the number of daily cases. So if we take the difference of the two values, say for yesterday we had the value, the cumulative sum, and for today we had the cumulative sum. So if we take the difference from today's cumulative sum and yesterday's cumulative sum, it will give you the value of today's COVID cases. So confirm New Zealand and confirm New Zealand num values are here. So this is confirm New Zealand, all the values, and confirm New Zealand num are from the fifth, 1, 2, 3, 4, 5, from the fifth row and onwards, where the values of the confirmed cases are. So confirm New Zealand num from 700, row 700 onwards, row index 700 and onwards, gives the values from 22 December 2021 and up to 9th of March 2023. Let confirm New Zealand difference equal confirm New Zealand num, bracket 700 and then onwards dot difference, open and close bracket. So printing that, so for the first day 22 December 2021, there will be none printed because there is no previous value. So, and then for 23 December 2021, it's 71 because 13,719 minus 13,648, that gives 71. And the third value is 0, which is 13,719, which is for 24 December 2021, minus 13,790, that is the value for 23rd December 2021, and that's 0, and so on. Now let's make a simple 7-day moving average, then plot new moving average against the original data. Note that we only care about day 700 and onwards. Calculate a 7-day moving average. Moving average 7-day. Let moving average 7-day equal confirm New Zealand difference dot rolling window equals 7. Now this will take the sum of the 7 values, which is from that value, from that location, and 6 previous values. And then dot mean open and close bracket, and we take the average by dividing the sum by 7. And printing the moving average 7 values gives us this. Now To better see these values, let temp equal pandas.data frame open and close bracket. Let the confirm New Zealand diff column in temp data frame equal to confirm New Zealand diff dot head the first 17 values. Let moving average 7-day a new column in temp data frame equal to moving average 7-day dot head first 17 values. So when we print the temp values, temp data frame, it gives us this. Now we can see that confirm New Zealand diff values are this, and moving average 7-day. Now for this, so we take the first 7 values, so 71, 0, 136, 44, 33, 54 and 71, and we take the sum of that and divide by 7. So let's show the working. So for example, when we do 136 plus 44 plus 33 plus 54 plus 71 plus 61 plus 0, those are the 3, 6, 7 values, and we divide by 7, that gives 57. So we have 57 here, and so on. Now let's plot this. Plot original and moving average data. PLT.figure, fixed size equal 12, 16, so width equal 12 and height equals 6. So when we run that, it gives us nothing. So let's do the first line. PLT.plot of confirm New Zealand diff dot index. So confirm New Zealand diff dot index. So confirm New Zealand diff is this one, and dot index is all the dates from 22 December 2021 to 9th of March 2023. And let y equal confirm New Zealand diff. So this will be the values from confirm New Zealand diff data frame. And label equal original data, color equal blue. So let's plot that. Let's skip plt.legend open and close bracket because we want to have the legend, and that should print original data in blue. So confirm New Zealand diff looks like this. This is the original data. So we can see that it's the values are near to 0 up to here for about sometime in February 2022, and then it starts going up and down, and so on up to March 2023. There are a few places, there are a lot of places which has spikes. Okay, so next we will plot the moving average. So plt.plot of moving average 7-day dot index. So moving average 7-day looks like this, and dot index is all the dates from 22 December 2021 to 9th of March 2023. So that will be the x-axis values. And then the y-axis value is the moving average 7-day values. So we can see that the first 7 values are not name values, so nothing should be printed there. and label equals 7-day moving average, color equal red. Let's plot that. Okay, so the legend is 7-day moving average and the line color is red. So the red color shows the moving average. So we can see that the first 7 values were not applicable, and it automatically goes to, okay, so it's not plotted over here. So you can see that we can only see blue line. And then the red line starts very on 0, and it is 0 up to sometime in February 2022. And then we can see that the moving average is takes the 7 values and averages that. So yeah, and so let's do the rest of it. Plt.x label, so we want to put the x-axis label time. Plt.y label confirmed New Zealand NUM, so we want to label the y-axis confirmed New Zealand NUM, and we want to put the title plt.title of 7-day moving average versus original data. So let's run that. Okay, so it looks like this.